Hi everyone, welcome back. In this Math 20-1 lesson, we are learning RF5, quadratic equations. We will solve by factoring, completing the square, and the quadratic formula. Then we will use the discriminate to predict whether there are two real roots, one real root, or no real roots. We will finish with problem solving. Please like the video and subscribe to the channel. First, solving by factoring. The big idea is the zero product property. If a product equals 0, then at least one factor must be 0. So, we move everything to one side. Factor the quadratic, set each factor equal to 0, and solve. Example 1. Solve x squared minus 7x plus 12 equals 0. Factor the trinomial as x minus 3 times x minus 4 equals 0. Set each factor equal to 0. So x equals 3 or x equals 4. Example 2. Solve 2x squared minus 5x minus 3 equals 0. Factoring gives 2x plus 1 times x minus 3 equals 0. Therefore x equals negative 1/2 or x equals 3. Next, completing the square. This method rewrites a quadratic equation as a perfect square. It is especially useful when factoring is not friendly. The routine is, isolate the x terms. Add half the b coefficient squared to both sides, write the perfect square, then square root both sides. Example 3. Solve x squared plus 6x minus 7 equals 0 by completing the square. Move negative 7 to the other side, so x squared plus 6x equals 7. Half of 6 is 3, and 3 squared is 9. Add 9 to both sides. Then x plus 3 squared equals 16. Square root both sides, so x plus 3 equals plus or minus 4. Therefore x equals 1 or x equals negative 7. The quadratic formula solves any quadratic equation in standard form. Ax squared plus bx plus c equals 0. The formula is x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. This is the most dependable method, especially when factoring does not work nicely. Example 4. Solve 2x squared plus 3x minus 2 equals 0 using the quadratic formula. Here a is 2, b is 3, and c is negative 2. Substitute into the formula. The discriminate is 3 squared minus 4 times 2 times negative 2, which is 25. So x equals negative 3 plus or minus 5 over 4. The solutions are 1/2 and negative 2. The discriminate is the expression under the square root, b squared minus 4ac. It tells us the nature of the roots before we solve. If the discriminate is positive, there are two real roots. If it is 0, there is one real root. If it is negative, there are no real roots. Example 5. For x squared minus 5x plus 6 equals 0, the discriminate is 25 minus 24, which is 1. Positive means two real roots. Example 6. For x squared minus 6x plus 9 equals 0, the discriminate is 36 minus 36, which is 0. That means one real root. Example 7. For x squared plus 2x plus 5 equals 0, the discriminate is 4 minus 20, which is negative 16. That means no real roots. How do we choose a method? Try factoring first when the trinomial is easy. Use completing the square when the question asks for it, or when you want an exact vertex-style solution. Use the quadratic formula when factoring is difficult, decimals appear, or you want a method that always works. Example 8. Solve x squared minus 10x plus 21 equals 0. Factoring is quick. X minus 3 times x minus 7 equals 0, so x equals 3 or 7. Example 9. Solve x squared plus 4x minus 1 equals 0. Factoring is not obvious, so use completing the square. X plus 2 squared equals 5. Therefore x equals negative 2 plus or minus root 5. Example 10. A ball's height is h equals negative 5t squared plus 20t plus 1. When does it hit the ground? Set h equal to 0. So negative 5t squared plus 20t plus 1 equals 0. Use the quadratic formula with a equals negative 5, b equals 20, and c equals 1. The positive solution is about 4.05 seconds. We reject the negative time because it does not make sense. Great work! For RF5, remember, set the equation equal to 0, factor when possible. Complete the square when requested or useful. Use the quadratic formula when you need a reliable method. And use the discriminate to predict the number of real roots. In word problems, check that your answers make sense in context. Like the video and subscribe for more Math 20-1 lessons.